course, and also in the ceremony of his speech. And we welcome him for the follow-up discussion from yesterday. And please, thank you very much.
Good morning, everybody. Good morning. I'm very honest with you. Yesterday afternoon, before the ceremony, I went to the wrong place. I came here. Instead of going to other campus, and it took me more than an hour to find out where should I be. And so when President showed up, I only 1 second behind him. This wasn't in time. So anyway, I hope you are enjoying the camp for the last 1.5 days. There are many more days to go, and I hope you learn something more. And today, I use the title Science, Technology, in Sustainability, Sustainable Development of Society. As I mentioned in my speech, this is really the most important issue we are facing today. As a young person, we are really facing an enormously important problem. And I will go quickly so we have time to discuss. Let's see. The keyboard control is different.
Is the here? Oh, sorry. You go.
Okay. After Big Bang, the universe was created, and it took almost 10 billion years before solar system was established. It's a long time. But immediately after the establishment of the solar system, the phenomenon of life started on the surface of this Earth. Because the situation is very different. So as you know, sun is burning now and emitting enormous amount of energy. And everything will follow the second law of thermodynamics. Entropy will be increasing, everything will become most probable state. It means most chaotic state. If we wait for another 5 billion years, the size of the sun will be expanding, and would be about the same size as the Earth orbiting the sun. So I'm sure 5 billion years from now, we won't be here. Mankind won't be here. That's a long, long time. And the interesting thing is, as I said, sun is burning, solar system is become chaotic, deteriorate as time goes on. But because of the phenomena of light, because of the photosynthesis, Earth is very different. Sunshine will irradiate a different planet. It will warm up and radiate the energy to the universe. Earth is very different. Earth will accept the photon, and then plant will grow, life will thrive. So in a sense that the chaotic material absorbing the sunshine become other material. That's the phenomenon of life. It's making it going. So that's really a special case. And entropy of sun is increasing on the surface of the sun. If you look at the phenomenon of life, entropy is decreasing. And decreasing of entropy is because of the increase of sunshine is more than enough to compensate. So, for quite a long time, for the last 4.6 billion years, phenomena of life made the Earth very different from the other part of the planet. And so, after 4.6 billion years, we came to a state that the Earth we are living in now. If we look at our ancestors, which appear on the surface of the Earth 2 billion years ago, about 2 billion years ago, 2 million years ago from ape to man. And during the last 2 million years, developed in the human society did not disturb the environment very much because the population was so low. And so this earth is not deteriorating, except in the sunshine. Sunshine will put disorder material into order. So very order, very complex creature like human being are still in existence. That all becomes science because of the sunshine. We eat lots of food and produce lots of waste. And total system is much more chaotic. Sunshine is put it back and make it very orderly. In evolution of human society for the last 2 million years, it's really part of the nature. Everything depends on the sunshine. And if you look at the society a little more than 200 years ago, this is an Aboriginal tribe in Taiwan. They were there more than 10,000 years ago, and that painting was done a little more than 250 years ago. It's a wedding ceremony. Bride and bridegroom from the parish, and somebody's carrying the name. But the thing I want to point it out to you is, if you look at this picture, almost everything, housing, clothes, the clothes and the decoration, and everything is coming from biomaterials, all made by sunshine. And our ancestors live on sunshine. The food production, energy, everything from sunshine. Around 250 years ago, the Industrial Revolution took place. Our ancestors invented the machine, internal combustion machine, sewing machine, and steam engine. And so efficiency of production increased tremendously, and human labor was replaced by machine labor. And the demand of energy became higher and higher. At the same time, we did find some dark stuff underground containing lots of energy. It's fossil fuel. So immediately after the Industrial Revolution, human society started to depend on the fossil fuel, not start to dissociate from sunshine. So you compare this picture compared to the last one, you'll find almost everything you have seen here, concrete, steel, and all this and aluminum, almost everything dug under the ground and use fossil fuel to transform it into cement and steel. So that change is really dramatic. We used to depend on what sunshine could give us. Suddenly we found lots of energy right underground. Like a child found out that the parents left some enormous fortune, so in the Spain. So we did start to change our lifestyle, science advances, and things started to change. And this is the example of how US changed energy usage. In 1850, 90.7% of energy came from wood burning. But by 80 years, 90.4% of energy came from combustion of fossil fuel. Only about 6.1% is burning wood. Nowadays, energy coming from wood burning has become a minimal, and combustion of fossil fuel certainly increased quite a bit. This is in the United States. And what are the consequences? When energy becomes available and science advances, we start to produce many things for human consumption. As you can see, all sorts of things. Chemists synthesized, made it available individual consumption. So in a sense, population increased, consumption increased, and even high-tech material started to become available. TV, icebox, and here I didn't show computers, iPad, iPhone, or Samsung's Samsung Note. All those kind of things is spreading all over the world, all over the world. And consumerism or individual consumerism become very rampant, and we are starting to use lots of energy, produce lots of good, and as the population increase, this is in the year 2010. When we started the 21st century, our population is about 6 billion people. 2010, we have 6.8 billion people on Earth. And this year, early in the year, we already reached 7 billion people. 7 billion people. At the beginning of last century, we have only 1.5 billion people. So population increased enormously. And together, all of us together, we are consuming about 1.4 Earth worth of resources per year. What I mean is, if you look at the forest and many other things, sunshine is creating on the surface of the Earth. We are using 1.4 times. It means we are doing deforestation and really damaging the environment. And if everybody live like people in the United States, it will take 5.4 times the Earth. And if you live like a British, 3.1 times the Earth. South Africa will need 1.4 times. Even people live in Argentina or Costa Rica, that kind of lifestyle, and the world will still consume more than Earth is giving us. Only country like India, if we live like Indians, and that population on Earth would then need 0.4 times the Earth. So if you look at this number, so we are consuming 1.4 times the Earth. What's your conclusion? You should say, gee, we seem to be overdeveloped. We seem to be overdeveloped. We're consuming too much. Too many people consuming too much. And so every time when we say developed country, developing country, I say nonsense. We have an overdeveloped country and not yet overdeveloped country. If you don't make it right, every time everybody says sustainable development, we look at the model for the development of the overdeveloped countries. And then we never solve problems. Of course, as the population increases, we produce lots of waste. The amount of waste is produced is enormous. So everybody look at this and says, most of these are made by chemists, synthetic material. But anyway, whether you're a chemist or not, we all together produce lots of waste. And that waste started by great impact on human environment. And especially during the last 50 years, those are showing mostly this is last 50 years, from year to year, or 50 years. You look at the carbon dioxide concentration or temperature going up, or if you look at the nitrogen concentration or global biodiversity loss during the last 50 years, we really start to give enormous impact to the Earth system. And this is really horrible. And when you look at all those changes, one thing which worried me most, and not only worried me, and worried many scientists most, is the global warming trend. As you see, sun is radiating the Earth, sunshine coming from top. Some of the photons I'm seeing, actually high above, short wavelength photon, shorter than 3,000 angstrom, oxygen will absorb, dissociate, and form ozone. So all the way down to 3,000 angstrom will be absorbed by the ozone. So O2 and ozone is absorbing all the UV photons. The visible photons start to come down. Some of them are reflected by the cloud, some of them are reflected by the ground, some of them will be absorbed by the surface, and some are absorbed by the atmosphere. Temperature of sun is very, very high, 4,000 to 5,000 degrees centigrade, and so light emitted is in the visible region. So if you look out, it's so beautiful. It's sun is emitting visible range. On the other hand, you look at the Earth, Earth is cool, maybe 20 degrees centigrade, so they are emitting infrared photon. You cannot see, because if you have an infrared camera, you can still see many objects at room temperature. We can see you. And the emission from the surface, some of them are going up from the radiation, and some will be absorbed by the greenhouse gases like carbon dioxide. Those are the main species of methane. And because visible photon will not be absorbed by greenhouse gases, but infrared photon, long wavelengths, will be absorbed by CO2 molecule or methane molecule. So as the greenhouse gas increases, light will come in, but not as easy to get out. So those heat absorbed by the greenhouse gas will radiate back, and some of them will radiate upward. And today, we do not have the greenhouse gases. The temperature of the surface of the Earth might be minus 25 degrees on average, because there are some greenhouse gases, so we keep it warm. But if the concentration of greenhouse gases increases, then temperature will continue to go up. More than 100 years ago, Arrhenius, who investigated chemical genetics, he did warn the humanity, and if we keep on burning the fossil fuel, you will see the carbon dioxide will cause the global warming effect. With Arrhenius at the time, he was living in Sweden. He saw Sweden will become like California, warm and comfortable, but without realizing that the global warming is really has much worse consequences. So that energy balance will not change very much, except as the greenhouse gases increases, you have to raise the temperature of the surface will be raised higher to emit more photons out to reach the balance. So greenhouse gas certainly will control the temperature of the surface. In 2007, some of you might remember, International Intergovernmental Panel on Climate Change, for IPCC, and Gore received the Nobel Peace Prize because the organization of IPCC and Gore pointed out that it's really a very dangerous consequences if we allow the temperatures to go up. So here we show the temperature before Industrial Revolution, and that's the temperature we have now. It means from before the Industrial Revolution, temperatures has gone up for 0.6 degrees. And as the temperature go up higher, and there will be different consequences. So if you look at the risk to unique and threatened systems, then currently we are already seeing lots of damage done by different climate. In risk of extreme weather events at the present time, the orange color shows it is happening, where the color becomes more reddish, and that will become very serious. So recently, especially during the last 10 years, did they see flood and drought is taking place all over the world. In a single place, you say, well, we have a flood, but I don't have anything to do with global warming. You do the global statistic, then you can see that the temperature rises, and flood and drought are really correlated very strongly. Well, so the risk of extreme weather events in the present weather is already pretty bad. And distributional impact is not as bad, and you look at the aggregate impact to the entire human society, but because some of them will be a positive change, some of them will be a negative change. So majority of people adversely affected is not really that bad. But this column is the most important. The risk of large-scale discontinuity at the present time, we don't worry about. Suddenly temperature changes and we cannot survive. So at that time, European scientists gave 2 degrees C above pre-industrial temperature, and so there's a so-called guardrail, 2-degree guardrail, and the reason everybody said we maintain 2 degrees from pre-industrial revolution region is, also we will suffer. As temperature goes up, we will suffer, but we don't have to worry. Discontinuity, it means temperature rises, suddenly ocean cough up lots of carbon dioxide, methane, or from tundra in Siberia, lots of methane shooting up, and temperature control goes up, and we cannot survive anymore. We don't worry about it. So people say, okay, try very hard to keep the temperature within 2 degrees centigrade. 5 years has gone by. Scientists are finding things are really very serious, a lot more serious than is shown here. And this is the most recent publication by Smith and others. Recent was 2009. If you look at this, the risk of extreme weather events is already in a very dark orange region. It's pretty bad, and you won't be surprised to see that like 2 years ago, major flood in Australia last year, in Thailand, and this year there's a drought in the United States, and food production is affected. And then if you look at the extreme weather event, you allow temperature to go up to 2 degrees, it's not the white color anymore, it's the orange color. It means we do have a chance that our climate will go to discontinuity. Once it's go to discontinuity, human beings is really very difficult to survive. And that's a very dangerous thing. And how soon we get there, that's something we want to discuss. It's interesting, you look at the major flood all over the world, and look at different continents, and you see from 1950, 60, or up to 2000, it's keep on going up, going up. Every continent is going up, and if you are at 2010 last year, that will shoot up high, very high, go through the roof, and that will increase. The only place in that statistic showing that the flood is not increasing is in Australia. So I have a friend in Australia. He always said, "Recently, I told you you should come to Australia. Long time ago, you worried about nuclear warfare. Australia will be isolated. Nobody will bomb us. It's a nuclear weapon. We have nothing to do with the Cold War. So you should go there." And said, "And we don't have flood." And as soon as he said, you see, this is Australia. 2 years ago. Entire area of the northeast Australia was immersed in water, and it says there's no degree of proportions. It means it's only happened thousands a year, every 1,000 years. So if you put this in, Australia also follow the trend. So drought and flood, if you look at independent place, like in Israel, is sitting there, you see the drought or the flood, so might not have anything to do with global warming. But if you look at the entire globe, you will be convinced this is global warming. It's almost like this. If I take a uranium atom and give it to you and say, look, this uranium atom lifetime might be 1,000 years. So I said, why don't you look at it when it's decayed? You tell me. You will sit there and look at the uranium, and it's not decaying. Then suddenly it's decayed after 300 years. And you say, why decay now? And that was almost the same question. People in Japan said, this big earthquake, more than Richter scale 9, should happen once every 1,000 years. Why this year? Why not 1,000 years from now? Well, if I take 1 million uranium atom and distribute it to 1 million people, ask everybody to look at the uranium, raise your hand, when you see decay, then you see 1 million uranium atom decay will be exponential. No? No, you cannot determine the lifetime by yourself. It's ensemble, you can see the lifetime on any nuclear atom decay with the probability. So this is really quite serious. And when we said maintain at 2 degrees centigrade, people said, when look at the energy balance, it is quite clear. We should not allow carbon dioxide to go beyond 450 ppm. That was the 2007 IPCC assessment. 5 years ago, we said we should not allow to go up beyond 250 ppm. How much right now? It's 390. And when you go up to 450 ppm, just toss a coin, 50% chances temperature go up to 2 degrees centigrade. It was assessment made in 2007. Now scientists will tell you it will go up to 2 degrees centigrade at 450 ppm. In the way we are doing, by the end of the century, temperature might rise 4 to 5 degrees centigrade. And that is really very, very serious. Very serious. And so, for many years, we said 2 degrees centigrade would pose an acceptable risk to key human and natural systems, according to global consensus of scientists. Scientists, 99% now believe in the global warming trend, but in the populace in the United States, only up to 70% believe in it. But 2 degrees centigrade is not good enough. But accomplishing 2 degrees centigrade, limit the temperature rise to 2 degrees centigrade, is not easy either. Politicians are not ready to compromise. So as I said, the program is discontinued. When that happened, everybody will come. Well, as I said, population is increasing. Now we just passed beyond 7 billion people. And United Nations made an estimate by 2050, population will go up to 9 to 10 billion people. And because diet is improving in many countries, especially in Southeast Asia, diet is improving. So conversion of meat from grain is a very low factor. If you want to produce the beef, you will need 5 pounds of grain to produce 1 pound of beef. It might take 4 pounds of grain to produce 1 pound of pork, 3 pounds of grain to produce 1 pound of chicken. And because the diet is improving, so we need more food. So the United Nations said by 2050, we need 80% more food production. And said that's the challenge for science to do. Well, scientists say yes, we may be able to do it by going to gene-modified organism. This is really happening in many parts of the world now. On the other hand, people working on the climate change say no, because extreme weather will reduce the food production. And today, if you look at the global market, food price is up, and I can expect to see the price will not likely to go down easily, because extreme weather will become worse and worse and worse, and the food production will be affected by extreme weather and loss of the agricultural land. One thing we didn't pay as much attention to it is everybody talks about GDP, but nature is providing lots of free service to mankind, and that is about twice as much as GDP. For example, if the butterfly and bee would not do the pollination, we don't have the fruits. several years ago, in one hair producing county, bee disappeared. And hair production went way, way down. So they asked government, help, we need bee. And government said, how can we help? It's better for you to use the ladder to pollinate yourself. So I saw the picture on TV. So the farmer climb up the ladder using phaser to try to pollinate flower after flowers themselves. And that was what bees been done free for us. And so 1/3 of the food we are eating is pollinated by wild insects. Cost over US $200 billion. And nature is really providing a lot of service. So when biodiversity starts to lose, we will not be able to survive. We're gone altogether. And when you look at agriculture, it's also interesting. If you pick up the piece of bread and start to eat the bread, you might not realize that 30% of the bread nowadays came from fossil fuel. It is fossil fuel prepare the fertilizer make the bread. So 30% of the bread is coming from the petroleum, fossil fuel. And so you can see that the cheap energy is penetrated in all areas of life. And we have to wake up. The reason I say we have to wake up is if we keep on going the way we are doing, within 30 years, we are coming to a very, very awkward situation, very dangerous situation. And I think you remember my lecture and said, yeah, Professor Lee said, 30 years ago, things would be bad. We might be saying goodbye. But before you say goodbye, you better send me a fax or send me an email that Professor Lee, what you said is right. That will happen 30 years. 30 years for young people like you might be reaching almost 50, still young. But the 60s, many older generation people who said that Professor Lee, it might be too late now, not much you can do, and then next sentence is horrible. Say, you will not be here 30 years from now. I won't be here 30 years from now. And that is very irresponsible. So I always try to challenge young students, don't trust people who will not be here 50 years from now, and try to discuss what will be happening 50 years from now. So we have to wake up. It's time for us to wake up and accede to the fact that our world is overdeveloped. We have too many people consuming too much resources, producing too much junk, and that is going to cause enormous problem. Of course, there's alternative ways of development. When I was young, during the Second World War, because Allies was bombing Taiwan every day, school was dismissed. I went to the mountain, lived in nature, and really live like this. It's a wonderful time. Learn from the nature, and at that time, we didn't have anything. Everything we live on is depend on sunshine. We plant vegetable, plant food. The clothing is also provided by biomass. Everything provided by biomass. Then, if I look at my lifestyle, tremendous change. One person can live with 100 watts. But if you go to the United States, people will be using more than 10 kilowatts. And so the question is, how much energy you need to keep you happy? On the weekend, you can drive around, go to shopping center and do all those things. You can also sit in the park and listening to music. Last time I was in Portland, Sunday, wonderful day. I was in the park listening to a brilliant young pianist playing Chopin's music. Everybody seems to be happy. So lifestyle really will change. So alternative way for development we have to look at. But the point is this, we do see everybody talking about we have to go to low carbon society. By 2050, we have to reduce the emission, maybe much below 3 tons per year. US is emitting about 18 tons. Australia, Canada is around 18, 20 tons. You go to Korea, Taiwan, about 12 tons. China already catch up, they are producing 6 tons. Only India, African country, low. So when we say, okay, we're going to low carbon society, what we meant is that we will have to go back to sunshine. Unless you use the energy which left behind when solar system was created, like nuclear, geothermal energy, those are the energy left behind when solar system was created. Most of the energy human society depend on is sunshine. So, back to sunshine. Sun in an hour transmit enough energy to the earth. That amount is about human society use in a year. So it means sun gave us energy covering over the world about 10,000 times more than what we are using. So of course, young people say, if we're smart enough, we certainly can go back, depend on the sun, and go back to nature, go back to sunshine. And that is really what important thing to do. And that's depend on the science and technology. Over the last 100 years, when fossil fuel is cheap, readily available, we didn't pay attention to use sunshine more effectively. Instead, in a hot sunny day, sunshine is irradiating the roof. We just burn more fossil fuel and turn on the air conditioner and push the heat away, using heat. So we really have to change. And some of the things will come from advancement of science and technology, whether photovoltaic or inventing catalysts to split the water, and there are many ways pointing to the sunshine. And at the same time, our technology should not continuously be for individual consumerism. Everybody wants to do things yourself. When I was young, I used to go to the movie theater, 1,000 people watch one movie. Now, everybody watch their own movie, and sometimes young people watch 2 movies, two TV, and watch 2 movies at the same time. That's amazing, but many young people can do that. And sometimes, I would say sometimes my son has 2 computers, always in front of him, do all sorts of things. So technology really should be for community rather than for individual consumerism, and we have to respect some culture and tradition. Ancient times, we didn't use so much materials. We managed to live, and we have to sit down and talk about what kind of society we want to make. One of the interesting things, when I saw African scientists, and when they listened to my lecture and said, entire world is overdeveloped, African scientists would say, Professor Lee, don't say that. Please, please don't say that. Don't say the world is overdeveloped. Africa is miserable, we need to develop. I said, I agree. Africa is miserable, you need to develop. But not develop the way America or many Western countries develop. Depending on the automobile, depending on the high consumption, we should develop in a sense that in harmony with nature, and depending on sunshine, we can live happily, and we will have an alternative way. So we have to sit down and discuss what is the way we should develop rather than using so many things unnecessarily can destroy the world. Yesterday, President Shimon Peres talked about we are in the globalized world. Certainly, every day, thousands of airplanes and people transfer the skies, and numerous goods cross the seas. The scourges of disease and environmental problems do not respect national border. And probably you might not realize that on the surface of the earth, atmosphere is a very thin skin, very, very thin skin. Even if you go up to 10 kilometers, airplane is flying, actually flying at the altitude of 1 kilometer. Here it's already thin, 1/3, and go up another 10 kilometers, and the air is thinning out. So atmosphere is very thin, and we are contaminating the very thin layers, very fragile. And we also know that in the world, widespread of poverty, disease, illiteracy, unemployment, and inequality will never be safe. We really have to build a equitable society. But when you believe in me, the global warming trend is going to be a big threat for all human beings, then you have to come to the conclusion. Enemies are not only coming across the border, we are creating our own enemy by allowing the temperatures to go up. So within 3 years, we see drought, flood, extreme weather start to become discontinuous. And just like a Martian come and over the earth, will be maybe destroyed. Maybe Martian might be much kinder than what we thought. We don't know. But anyway, so I mentioned yesterday in this minimum speech, everybody thinks the nation state is the way to solve problems, but problems become more and more global. We do have to learn to work together, and enemy of mankind is our own, and that we have to fully understand. And yesterday I said we spent $1.7 billion for defense, and those money should really use it to find a global solution. And in the past, it has not been easy. But now, we are in a very different situation. We can now be globally connected. As I said, internet can make everybody connect together. If we learn to organize, learn to talk to each other, then we can solve the problem. Yesterday I mentioned briefly, I'm the president of the International Council of Science. This is the organization try to strengthen the international science for the benefit of society. 121 nation members. But although we have such a fantastic organization, headquarters in Paris and 3 regional offices, we're working hard. But we really need to get the international science into global science. There are all the national boundaries, they are fighting each other in like real meeting. Some good suggestion, one country will say, no, I don't like it. Another suggestion, other country doesn't like it. At the end, the suggestion left behind is no any bite, not very important. So we have to learn to work together and just forget about the national boundary. So I want to conclude remark. We must act with fierce urgency of now. The coming decade will be about transformation and action. We aim for nothing less than a sustainable, just, and equitable human civilization, and we need to find a new way of development at once in harmony with nature and tackle poverty and starvation. The world today is much more complex. We all need each other now. Politically, there's scientists, citizens. The only way we make it is saying this, many of you might be scientists. Scientists does have a social responsibility, and knowing what's going on, we are the generation to take action, engage in transformation. Otherwise, we'll be the first generation to be globally connected. We are going to be the first generation to start to disappear from the surface of the earth. It's a serious problem. So, if you listen to my lecture, I hope you cannot sleep for many nights. Start thinking about it. You can go home, sleep as usual, then I will start to worry. But thank you very much for listening to me. And we can discuss further.
Do we have a few minutes for questions?
Yes.
Questions? Yes. Yeah.
Thank you, Professor, for your lecture. The question that I would like to ask is that you mentioned that the global warming is very the hot topics around the world. And I thought that I have read many newspapers in the past year, like they have done like a CO2 summit or other global warming summits, like in Kyoto and like in Nepal is near the Himalayas. Like I don't know that place. And the thing is, many leaders, they haven't agreed on when they did the summits, they didn't get a result or the solutions. Like sometimes like in Kyoto CO2 forms, like they quit from that forms because they didn't agree. And now it's coming, it's like they did like a airplane which produce a lot of CO2, so they try to reduce it. But the European Union, they agree on it, but China doesn't agree on that. Like such kind of things. And you mentioned that now the world is overdeveloped. Actually, it's like in the developing countries, like us in Myanmar, we don't have like too many industrial and other big machines, but the US they have been already developed, and in the business time, like we go to the first primary, how can I say, like primary sector is like we do agriculture and some kind of like traditional business, and the second sector is like we did a lot of extracting coals, mines, and other like manufacturing, and the tertiary sector is like banking and other services. But to be a developed country, we have to meet with the tertiary centers for service, banking, insurances. But when the developing countries, they try to upgrade their industry and other things, but the developed countries like US or other Canada, they try to stop us, like, oh, you're producing too much CO2 and we have to stop this. I think it is inequalities of this. Yeah. So how can we solve these globalizations in the future?
Well, that was one of the major problems, because every country is the way of development, the structure of the city, the way agriculture was done. So in the United States, if you lose the job, you cannot survive. So we said, your GDP is so high, when you lost the job, you cannot pay for the mortgage, you cannot live. So politicians will try to maintain their job. And those are quick solutions. They will not change the social structure. They will not change the city structure. In the 1970s, there was an energy crisis. People from the big city started moving from suburb to the center of the city because energy became expensive. Then as soon as energy price went down, they all expanded out again. So I was saying, for so-called developing countries, we should not look at the United States or some other overdeveloped country as a model. They are not as efficient using the energy. In Los Angeles, young people cannot do anything without owning an automobile. With Myanmar, you don't have to have an automobile, you can do a lot. And so how we develop the society, so we use minimum amount of energy, minimum amount of resources, and get a heavy slide. And that's the challenge for us. If you look at the 20th century, industrial development in the United States is based on the automobile industry. So many countries are following it. China used to say that the yes, automobile industry is a locomotive for bring up the society. So they expand the locomotive industry in many parts of Asia, going to the automobile. When you go to Paris and London, the public transportation and subway system are more complete. You do not have to depend on so much on the automobile. So France using nuclear power and depend much more on the public transportation. Per capita emission is only 6 tons, about 1/2 of the emission done by Korea or Taiwan. So I think so-called developing countries should develop sustainably, not fall into the very bad wasteful lifestyle. That is the important point.
Let's give the chance for a different person. Yeah. Yeah.
Okay. Science requires reasons, right? But some culture which can be part of nature's are full of beliefs which requires not any reasons. How can these things combine?
Combine what?
Combine science and being with a part of nature.
Yeah. You see, long time ago, most of the people live close to the nature. That was before the big city developed. So when I was young, I lived close to the nature and for several years lived in the nature. But now if I look at my younger generation, they live in the concrete block, in the city, in the apartment, and very often said, well, let's go hiking. Young kids said, are there air conditioner up on the hill? I said, no, it's cool in the mountain. But the young generation seems to be detached from the nature, living in a very artificial structure, and children, number of children are small, so they came home either alone or one brother or one sister. Very different from when I was young. All the neighborhood kids are all together, my cousin and my relatives were all together, and we play music together, play sports together, and live like one community. I remember Hillary Clinton in the White House said it takes a village, and the word was taken from the African tribe. They tried to tell other people that it takes the entire tribe to educate youngsters, not a family or father and mother. That would not be enough. Family is important. You really need the tribe.
Okay. I will have to the last question. I will have the privilege to ask you the last
Yes.
question. Let's suppose that in 20 years we find a way to harvest solar radiation,
Yes.
and we will have huge amounts of energy at a very low price.
Yeah.
Wouldn't that bring a problem of over-consumism? Because we will have low energy, a lot of energy at a very low price. We can buy everything we want. We will generate much more waste than we generate today. So, in some way, the solution may be a problem by itself.
No.
Okay.
I think at the present time, when we said go back to sunshine, right? Go back to sunshine. Energy comes from sunshine. And in that process, you have to analyze some other things. We say we have too many people consuming too much resources, and we cannot, because of we have more energy to consume the forest and other natural resources, human society will be doomed also. So, you see, if I say we have too many people consume too much resources, we have to control the population. Not too many people will agree with you.
Yeah.
I said it's a very difficult thing to do, but we should do it, control the population, otherwise we will not be able to reach it. So United Nations said by 2050, we have about 9 to 10 billion people, the food consumption should increase by 80%, and so on and so. I said, no, no way, no way. You really have to change. You should understand too many people.
Thank you very much. So, Professor Lee, you have the next group. We have a short break now, and we all go to our specific places. You all know your guides are here, right? Yeah.
I hope you go home boring.